Okay, let's get started. Welcome to the YouTube channel. We're going to start with Chapter 1.1, Expressions and Formulas. And the first thing I want to do, though, is I want you to make sure we're paying attention to vocabulary. So I want to start with expressions versus equations. We're talking about expressions in this section, but we want to compare that to what you get with an equation. Now, an expression is numbers, variables, operations, okay, any of those together, where variables are for the unknown quantities. But the thing is, that makes them very different, is that there's no equal sign. Okay, that's important. And over here on the equation side, you always do have an equal sign. So that should be pretty straightforward and a very fundamental difference between those two. So then it comes down to, what do I do with expressions and what do I do with equations? So, and that goes back to the directions you're going to see, things like that. You know, you don't want to be simplifying an expression and then somehow magically come up with x equals 3. You know, we're not solving everything. So, of course, we solve equations, but we can simplify expressions, and we'll get into that. Or we can evaluate expressions if there's no unknown variable. So if you know the values for all your variables, then go ahead and evaluate it. You'll come up with a number. Okay? Simplify is going to leave it with some numbers, some variables. Okay, so big difference is there. Okay, so of course when it comes down to evaluating an expression, we're going to make sure we're using PEMDAS, which, as you remember, is the mnemonic that we use to remember the order of operations. So the P in PEMDAS stands for parentheses, but what we're really getting at is, of course, grouping symbols of any kind come first. So let's spend just a second and talk about what are the possible grouping symbols. Obviously parentheses. So two curvy lines, like so. But you could also have brackets. Pretty obvious. Braces. Sometimes I forget the name of these, but they're the little squiggly ones. And here's two more that are a little more unusual when it comes to grouping symbols. You don't think about it, but it is a fraction bar and an absolute value symbol. Okay, so all of those things would be grouping symbols that say, hey, do me first, or at least group this together. All right, so do your grouping symbols. Of course, the next E in PEMDAS is for exponents. So if you have anything raised to a power, make sure you do that next. Okay? And here's where I'm going to bring up one example for you. If you have, you know, minus x squared, well, let's make it 5 minus x squared, and you know that x is equal to a negative 3. Okay? When you make this substitution, please, 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 when it's a negative number for a variable, use a parentheses to make that substitution. You always do the substitutions first before you do anything else, just to take a good look at it. And now you can see that negative 3, the entire thing is being squared. So the negative is being squared and the 3 is being squared. Okay, so do that first. 5 minus 9, because of course negative 3 squared is 9. Okay, and then you have the 5 minus 9 minus 4. Many of us do that wrong. It's a common error, and I just want to set that straight right away. Okay, here's another common error that people make when you're reading PEMDAS. You want to do the multiplication first and then go back and do the division, because that's the way it's listed in PEMDAS. But of course, multiplication and division should go together. Okay, they're really just two forms of the same operation. Okay, so they go together. Left to right is the way you know which one to do first. So if you have 18 divided by 3 times 6, you would do the 18 divided by 3 first, and get 6 times 6, and you'd get 36. Watch what happens if you don't do it. If you'd want to do the multiplication first, you would have 18 divided by 18, and guess what you get? You get 1. So this was wrong. It's left to right, no matter what. If it's multiplication or division, they go together. And I'm going to remind you then, since you know that much, that addition and subtraction for the rest of PEMDAS are the same way. They go together, left to right. And that should take care of it. Okay, so here's a problem for you to try this. I want you to evaluate this. That's 6 minus x squared divided by 2, and that is all over the absolute value of x minus 7. Close that absolute value, and then plus 1. Try it. And here's where, when you get these U-tries, at this point you're going to pause it, and then turn it back on when you have your answer. So go ahead and pause it. Here's the answer. Okay, the answer was the negative 1 over 6. Boy, remind me never to use 11 when I'm working with absolute values again, because that was a bad choice. I even chose the 1, which I should have known better. But it's a little awkward, but you can make it out, I hope. If you got that answer, that's great. I do want to point out, when you're doing work in my class, you must circle or box the answers, okay? So make sure you're doing that. If you want to hear the solution, it's here for you, and let's move on. Okay, formulas. Formulas are nothing more than an equation that you've made by sticking a label on an expression, So, the force between two massive objects is proportional. It's GMM over R squared. Let's just say that. That's a formula. Tells you how to use that. Now I'm going to trust that every one of you is able to use a formula. I can give you any generic formula from anywhere, and if I give you everything you need, in this case I'll give you G, the little m, the big M, the R, if I give you all of those, you could find F for the force between these two massive objects. Alright, what I want to do though is I want to go one step further and say, take a formula like this and see if you could solve it, just rearrange it, solve for a different variable. So this time let's solve for capital M, and how would you go about that? So I just want to be able to isolate the m, and so I'm going to multiply both sides by r squared. F r squared is equal to g little m big M, and then I'm going to divide both sides by the things, in the way, the g and the little m, and that's equal to big M. And that would be that equation solved for big M rather than solved for F. Okay. So we can do this. It can get a little trickier when you have to factor, things like that. A quick word about real numbers and their classifications. That's going to be an additional assignment for you, so I'm going to skip it. I'll just say you don't need to worry about abbreviations. Please just spell out the words. There's too many I words, there's too many R words. Let's just spell them out so we know exactly what we're talking about. So that's enough about that, and the rest you'll do yourself. And as far as these sort of properties like the commutative, associative, etc., I'm not going to say much about those either. You won't be tested on them. You will be able to use them, okay, without naming them. But obviously we know distributive property and inverses as well. So I just want to point out inverses real quick. If I give you an inverse of, let's say x, what would that be? Obviously, we could do 1 over x. The idea behind a multiplicative inverse, I should say, and that's what we'll refer to when I say inverse, that's what I'm referring to, 1 over x. It only gets a little bit trickier if you do another example, the inverse of x minus 2. And what do you think that is? Think about it for just a second. That's my answer. It's not a fraction bar. It's my answer line. But that answer would be 1 over the x minus 2 is kind of grouped together. You can think of it as having parentheses, but of course it doesn't need them because it has the fraction bar as a grouping symbol. Alright, so making sure we know inverses. The other thing that's good is to have what you could refer to as an additive inverse, but we're going to refer to it as an opposite. And those are the things when you add them together, they make a 0, okay? So, additive inverse, which I'm not so keen on those words. So, if I give you the opposite of 3 is, answer, -3, what is the opposite of x? And the answer would be -x. Of course, you can go the other way. If you had -15, the opposite of that would be +15. You don't know, this is I said -x, but you don't know if this final answer is going to be a positive or negative number, because x could have been negative to start with, so just be careful about that. And it only gets a little bit trickier again when you have these kind of binomials, to skip ahead a little. If you said the opposite of x minus 4, what would its opposite be? You would have to put a negative out front of the entire thing. Again, those parentheses are very helpful. And you could distribute the negative, and you could use commutative to write those in a different order. Call that 4 minus x. So I actually like this as my favorite representation. The opposite of x minus 4 is 4 minus x, and that's something you want to be able to recognize pretty quickly. Alright, we do want to be able to simplify expressions. Oftentimes we do that with the distributive property, using that, and then combining like terms. Let's go ahead and define terms. It's important to know that terms are variables, numbers, a group of those that are separated by addition or subtraction. And you're going to hear me use the word terms quite often, so you should be able to count the number of terms in a expression, separate the terms, things like that. Distributive property you should be good at. So let's just take a simple one and see if we can do this you try example. Okay, so you try this one. Here's your problem. Make sure you get it back into its simplest form. There should be all your like terms are combined, things like that. Go ahead, pause it now, and come back when you're done. And your answer, here is your answer, the 26q minus 32r. So in these cases, without fractions and numerators, denominators to worry about, simplest form is really whenever you have finished distributing and combined your like terms. Okay, I think we'll stop there. That takes care of the first two sections, and pretty sure we're just getting vocabulary set. If you're having trouble with any of this, make sure you come and see me, because we're going to move pretty quickly. All right, see you, class.